Hi, my name is Nur Syafiqah Tunisa binti Sabi'i and my matrix number is 201151425. Making this video for ENT115 Analog Electronics 1. So in this video, I would like to demonstrate a common collector amplifier circuit for our lab 2. So, the first part of the video is current and voltage characteristic of BJT. And by referring to the circuit in the lab sheet, we can add NPN BJT to the circuit here in LT Spice. It was asked to use a 2N3904 for this experiment. And then we add more components to the circuit, which is this resistor and voltage sources. So shift R, control R to change the direction of the resistor, and then we add voltage source. Put it here, one, and second one is here. Again, we can put a ground to each end of the connection, and we can add wire to the circuit to make a connection to each of the components. So once connected, we can add a value, which is resistor is 100k ohm, and then for this voltage sources, we use two voltage sources because one for VCE and here for VCE, and this one for VBE. So we can edit simulation command DC sweep. This one's VCE, and double switch linear. Start value is 0, stop value is 10, and then for the increment we can put 0.1. And the second source for VBE, stop value is 0, start value is 0, stop value is 5, and with increment of 0.5. And can put it here and change the name for this. We can refer it as VBE, and this one for VCE. So once the value to the component is added, we can also add a part, which is V1 here, VB, to here, oh not VB, it's IB, here, and then IC here, and that's it for the circuit of part A. So once done, we can run the circuit addresses. We want to add ICQ1 for the result. So here results. This one is for VCE, for the y-axis is V. Not for you. This one is IC. This one is VCE, and each of the line is for IB. IB is 0, and then 5 micro, 10 micro, 15 micro, and so on, with the increment of 5 microampere. Next, in the second part of the video, which is part B, I would like to demonstrate on small signal common collector amplifier. So again, by referring to the circuit in the lab sheet, we add a 2N3904 NPN BJT to the circuit. Choose 2N3904 and then add more components, which is a resistor first. Resistor. In this circuit, we use 4 resistor, which is for R1, R2, RE, and RL. And then we can add a capacitor, control R, capacitor over here, and second capacitor here. And next, add a voltage source, 2 voltage source. We use 2 voltage source for this circuit. Put a ground first at the end of the connection here, and draw wire to make all the connections are well connected. So once all is connected, we put on the value for each of the components. For the voltage source, for this voltage source, it was given in sine. So click on sine, we put 0 with 20 million of frequency, amplitude, MV, and 5k hertz. And then for the capacitor 1 is 2.2 microfarad. R1 is 2.2k, 22k. R2 is 27k. And then R is 1k. And for the RL, you can change it to RL, is 1k. This one also RE. Then we can put in part for the V-in, for the V-in here, and then VB at the base of the BJT, and then collector voltage VC at the collector, and then VE at the emitter junction. And last but not least is the V out here. And then we also have to put transients, that is simulation command, transition 5M for the opti is also 5M. Click run to run the circuit. Addresses, we want to find VB, VE, addresses, VIN, and V out. Okay, so V and V out is used to find the amplifier gain, which is a V of equals to V out over V in. So we will use two of these graph, and for V and VBE to find the DC values. So that's all for the lab 2 common collector amplifier.